Alright, A, B, and C are the locations of 3 support posts. The bearings from post B to post A is 45 degrees. The bearing from post A to post C is 135 degrees. If the distance of AB equals 8 meters and the distance of AC equals 6 meters, what is the bearing to post B from post C? The bearing is approximately blank degrees. Hint, use inverse trig ratios to find the measure of angle ACB, and use the fact that the segments representing due north are always parallel to find the bearing from C to A. Then subtract angle ACB's measure from that bearing to find the answer. Enter your answer as a number that correctly fills in the blank in the previous sentence. If necessary, round your answer to the nearest degree like this, 42. Okay, that was a long hint. So I'm just going to start with filling in the information that's not on the diagram already. So I know that AB was 8 meters, and I know that the distance from A to C was 6 meters. They do have this marked as a 90-degree angle, and it wants to know what is the bearing to post B from post C. So they're starting from post C. They want to go all the way around to post B. They want to go back to this line right here. So they want us to find this angle measure right here. So the first thing that I'm going to do is I'm going to remember that in a circle, it's 360 degrees. Now in this circle, I have 3 angles. I have this angle formed by A and C in due north, and then I have this angle right here, and then I have this angle on the outside. So I'm going to find these first 2 angles and subtract them from 360 degrees. So that is my plan. So now, let's just start with that plan. So again, that was 6. So I'm just going to focus on this angle here first, because it's part of a right triangle. So if I want to find this angle, I'm going to label this triangle according to that angle. So the side directly across from it is going to be the opposite side length. The side across from the 90 degrees is the hypotenuse. And the side touching the angle but not the hypotenuse is the adjacent side length. So then again, I'm going to remember that if I'm finding an angle, I have the option that the angle, I could use the sine inverse of the opposite over the hypotenuse side length to find my angle. Or I have the option that I could use the cosine inverse of the adjacent side length divided by the hypotenuse side length to find the angle. Or I have the option that I could use the tangent inverse of the opposite side length divided by the adjacent side length to find the angle. So I'm going to look at what side lengths I was given. I was given the 8, which is the opposite side length, and I was given the 6, which is the adjacent side length. So I'm going to look for one of these that has relationship between the adjacent and the opposite side length. So this one's opposite and hypotenuse, so it doesn't have both of them, so I'm not using that one. This one's adjacent divided by hypotenuse. So again, it only has the adjacent side length. I'm not using that one. This one is opposite divided by adjacent. Has both the side lengths that I have. So I'm going to use my angle is going to equal tangent inverse of 8 divided by 6. So jump over to Symbol Lab. The angle is going to be tangent, and I'm going to pause, let it pull up that -1 for the inverse, and it was 8 divided by 6, Whoops, I'm not going to put a point there. I don't know why. And it says the degree is 53.13 degrees. So this angle in here is 53.13 degrees. So now I know one out of those three pieces that I wanted. So now the other piece that I want to find is this angle right here. Because again, remember, I'm looking for this part of the angle. And if I find these two pieces, I can add them together and subtract them from 360, and it'll give me that part of the angle. So now, I am going to erase so I can focus on this angle. So now we have, I'm going to erase these. I hope you wrote those down so you can reference them in the future on a checkpoint. Alright, so now let's look at this angle right here. Alright, so notice that due north and due north would be parallel lines, right? And this line right here is a transversal. So we know that we have 135 degrees right there, and I want to find this angle. So what's the relationship between these two angles? Well, they're same side interior angles. So again, remember that same side interior angles add up to 180 degrees. So I'm going to add it up to 180 degrees. I don't know what this angle is, so I'll just leave it as x. So I have 135 plus x is equal to 180. Well, 135 is being added to x. I know the inverse operation is to subtract 135. So I'm going to subtract 135 from both sides. 135 minus 135 is 0. I still have a positive x. That equals 180 minus 135 is going to give me 45 degrees. Now this is most typically written as just x equals 45 degrees. So this is 45 degrees. So I'm actually going to erase these so we know that this angle right here is 45 degrees. This angle, again, was 53.13, and we're looking for from this due north to this side. So I know they're all going to add up to 360 degrees. So I'm going to add them all up to 360 degrees. So I have 53.13 plus 45 plus the bearing, so I'm going to use B, the bearing that they want from post C to post B. That has to equal 360 degrees. So first I'm going to add 53.13 plus 45. 53.13 plus 45. And that's going to equal 98.13. So then I have 98.13 plus B is equal to 360. Again, the inverse operation from addition is subtraction. Minus 98.13. 98.13 minus 98.13 is 0. I still have plus my bearing is going to equal 360 minus 98.13. 98.13. That's going to give us 261.87. So that's 261.87. And this is typically written 0 plus b is just 0. So our bearing is 261.87. This did say to round your answer to the nearest degree, and the nearest degree, 261.8, would be closer to 262 than it would be to 261. So this is 262, and that's how I would answer this question.